So now we've seen how we can define a class. We can put attributes in a class, including methods, such as an initialization method that says when I create a new instance of this class, here's what I want to do in order to store some values away. Let's see what other things we might want to do with objects, both basic operations of objects and then an example of using a class. So what happens if I ask an object what it looks like? In particular, if I say print it out. Well, if we don't do anything special, Python is going to use a unique but really messy looking or uninformative representation of an object. If I take that coordinate C that I created and I say print out what's the value of C, it gives me back this very funky looking thing here. It actually tells me at what location in memory it is. It tells me that it came as a version or an instance of a coordinate under the main or global environment definition, but it's not very helpful. I don't really care what memory location it is at. In fact, I shouldn't care what memory location it's at because I said I don't want to worry about that. I might want, when I ask what an object is, to get something more informative out. And so I can do that because, in fact, I can define another special method inside a class definition. And it's special. I'm going to designate that by having two underbars here. And it's an str or string method. And so this new method is going to be what Python will call when it needs a string to print out to say what an object is or what it looks like. So this method will be called with the object as the first argument, and it should return a string as its output. And so there's my coordinate definition. There's the init portion. Now I'm going to define another internal method. Again, only one argument self. It's going to point to the object itself because that's the standard procedure. And in this case, what I'm going to do is say return a string that has basically the little angle arrow, and then the value of the x coordinate, and a comma, and then the value of the second coordinate, and then a little angle arrow. So it's giving me a printed representation that this is the point 3, 4. What I want you to see is I'm now overriding the underlying object string method with this string method, and this is how it converts any instance into a string that will be printed out. So I can get information about what I'm looking at. And in fact, if I do it, that's exactly what I get. If I print C, having bound C from my earlier version, it prints out a representation that I just defined for what this object should look like when it tells me what it is. What else could I do with objects? Well, remember, we said every object has a type. So I can ask for the type of C. And it gives me back a kind of interesting looking thing. Some valuable information. It first of all says it's an instance of a class. Great. It's important to know. And then it tells me basically information about the class definition of which it is an instance. The main here is saying it's a class whose definition is bound in the global environment, but there's the name of the class. So this is essentially telling me that C is, in fact, an instance of the class coordinate. And that actually makes sense. For example, if I were to print out coordinate, it tells me it is a class. Great. And if I print out the type of coordinate, it says it's a version of a type. Both things that make sense. That is going to be useful because if I'm going to do some code and I want to say I've got an object, can I do something on it? I'd like to know what type is it. And I can check that with a straightforward thing. I use a procedure or a method, or a function rather, that's provided to us by Python called isInstance. And this will simply check to see if an object is an instance of a particular type. And I use it, for example, by saying, is C an instance of a coordinate? And we'll essentially take the type of C and check to see that that type does match up coordinate right here. It's going, if you like, inside of here to say, is this equivalent to that? In this case, it's going to print out true. So that's also really handy. Now, so far I've shown you how to override existing base methods. Things that have two underbars, a name and two underbars. Init's one, str is another. There are a few others that you can look up that Python provides for its objects or its classes. But I can add my own methods and not just change built-in ones. So for example, given that I'm talking about things in the plane, geometry, imagine I've got a point there and I've got another point there, and I'd like to know what's the distance to the second point. Well, I can define a method, an attribute, that is going to be associated with a point called distance. I'm going to load, and I didn't put it in here, I'm going to load up the math module inside of here so that I can inherit some math things, and I'm going to assume that SQ is just a little procedure that does squaring. But notice what distance does. First of all, again, its first argument is self. That's going to point to this instance. I'm giving it a second argument. So if C is one point, and I say, what's the distance from C, sorry, there's supposed to be a dot there, to origin, notice what will happen. I look up C in the global environment. It points to an instance. That's a frame. The dot says, inside that frame, get the binding for this name, which is the method I just created here. And I'm going to apply that method to self, which points to the instance of C, and other, which is going to point to origin, which is another instance. And then notice what I do. Inside of here, I get the x value for self, subtract out the x value for other. Each of those is going into a different frame and pulling out those values, squaring it, adding to that the square of the y value for self and the y value for other. I'm just doing Pythagoras' theorem and I'm getting out the values. But notice the reference. I use self.x to get the x value for this instance. I use other.y to get the y value for the other instance. So this lets me get out the pieces and then return an overall value. So now I can see, I can define classes. They will have some attributes. I can create instances, which will initialize to some attributes. I can create methods in a class that will apply to any instance, allowing me to compute new information. And those could be overriding existing methods or creating my own. In the next segment, we're going to look at a little bit more extended example.